So here we want to find all values of k so that the augmented matrix down here corresponds to a consistent system. So you've got our first row is 1k, 5, second row is 3, 6, 10. So we're trying to figure out what are the numbers you would be allowed to plug in for k here so that the resulting thing is consistent. Well, we should probably start with figuring out what does consistent mean. So consistent, remember, a system is consistent if it has at least one solution. So for a system, that means you can either have a unique solution, so that is just one solution, or you can have infinitely many solutions. So what we're going to do here is just start with row reducing this, and then once we simplify a little bit, we'll see how we could narrow it down so that it satisfies one of these cases. So what we'll want to do if we were doing our typical row reduction, we'd want to make this 3 into a 0. We could achieve that by performing our row operation. We'd want to take row 2 minus 3 row 1s, and that's going to be our new row 2. So since we have this 3 and the 1 here, this will give us a 3 minus 3, and boom, it'll be gone. So if we do that, the next step of our matrix would look like our row 1 is going to stay the same. We've got 1, k, and 5. And then down here, we'll do 3 minus 3 is 0. We'll do 6 minus 3 times k. We don't know what k is, so we're just going to leave that in like a variable. So this will just give us 6 minus 3k in this entry. And then here we've got 10 minus 15 gives us negative 5. Okay, and so what we can see here from this last row, we can analyze what's going on in this entry to figure out what's going to happen with our solutions. So what would happen if 6 minus 3k was equal to 0? Well, then we would have like a 0, 0, minus 5 here, and we know that when we have this, we end up having no solutions, also known as being inconsistent. But we're looking for consistent here. So then let's think about what would happen in the opposite case. So if 6 minus 3k was not equal to 0, then we would have, whatever this value is, our row would look like 0, and then some number, and then negative 5. So as long as this thing is not 0, we could divide by this and get a unique solution, and then we would be in consistent land. So you can see from our analysis here that as long as 6 minus 3k is not equal to 0, or if you solve this around, we could like subtract 6 and divide by negative 3. So as long as k is not equal to positive 2, we should have a consistent system. So it turns out there are a bunch of values satisfying our answer, right? It could be 1, 0, pi, a billion. Just as long as it's not 2, we should be in the clear.